Okay, in this final lesson of this chapter, we're going to create game-ready grasses. And if you remember, this is the same grass that we created in Cinema Edition, and we're going to optimize that. And there are a couple of ways to optimizing these grasses. And of course, I have opened that in Games Modeler. And the good thing is that if you create a tree inside Cinema Modeler, you can bring it into Games Modeler as well to use the optimization features that it has. So right now it has 20,000 polygons, which is of course a lot for something like this that is going to be used in games. And of course the grasses are something that are going to be instanced in the game, for example, a million times. And having so much polygon is really not the best way to do that. So we're going to optimize that. And the first method that we're going to use is going to the mesh cutout tab in here. In the materials, we're going for every material and open up the mesh cutout tab and start optimizing from here. And if you see it here, we have 33 vertices on this one, which is quite a lot for something like this. And we're going to optimize that. So to support the formation a lot better, we added a bit of the tessellation into this. So I'm going to disable the tessellation and bring it down, and now you see we have 14 instead of 33. So now let's set it to high poly, and now our high poly has been optimized a lot better. And for the medium poly and low poly, let's start removing some of the vertices. So I'm going to delete, because on the medium poly and low poly, we're not going to be seeing a lot of deformation because the medium and low poly are going to be shown from so far away. For example, a distance like this, and the deformations are not so useful in that situation. So let me delete these two as well. And now this is good for medium poly. Let's assign it. And for the low poly, let's go a bit more radical as well. I've removed those, and I'm going to bring just one up top in here, and let's remove these as well. Okay, this is the minimum amount that we can go, and I'm going to assign it to here. So you see that now we have come from 22,000 polygons in the medium poly. We're now right now halfway there, and this is good amount of optimization. So let's go and do the rest of the optimization as well. So I'm going to bring up the other meshes and start optimizing again. So let's hit edit mesh, and again I'm going to bring the tessellation down and assign it to high poly. And right now 20 vertices is something a bit too high for this, so I'm going to remove some of these vertices. And we added these vertices in there to support a lot of the folding features for the high poly. But for now, we really do not want these high poly features. So I'm going to decrease as much as I can from these. So let's assign this. And we went from 20 to 11 vertices, which is good for having this grass patch. So let's go for medium poly, and I'm going to remove even more from this. No, not that one. Let's bring this one and create a new. Okay, now let's assign this to medium poly, and for low poly I'm going to delete even more from that. So let's clear these masking sections so that they do not come in the way. And I'm going to create this, and this is going to be used in the LOD system, and assign this one to the medium poly, low poly. So right now we're in Cinema Modeler, but that doesn't matter really, because the mesh cutout system is the same across both of them. So let's go for Alt Cutout 2 again, and we're going to optimize this one more. So let's decrease the tessellation, and now we have 14, and this is somehow good for the high poly. So let's see if we can go more a bit, removing a couple of these vertices. Okay, this one is for the high poly, and remove these. And since we have too much alpha cutout in here, I'm bringing these down to tighten up this part. So this one for the medium poly, and this one, let me see where I can delete from here, and these, instead I'm bringing just one vertex, and bringing this one up here, and this one to here to support all of the features. So this one for the medium poly, the low poly, excuse me. And now you see we have gone from 22,000 to only 5,000 vertices, which is a huge optimization without losing any quality at all. So for now, I'm closing this cinema version and opening the games version and opening the same scene. Okay, now we are in Games Modeler, and this is the model that we loaded in perfectly without any problem. So one of the cool features that a speed tree for games has is the ability to set the LOD system for this. And LOD stands for level of detail. And this LOD, or level of detail, divides the model in here into some levels of details as you assign them. For example, if you want to have 3 levels of details, one high, one medium, and low, it's going to show the highest detail when the player is closest to the model. For example, if the player is walking through these grasses, it's going to show the maximum level of detail. And when the player is going to walk away, for example, in such a distance, you really do not need to see whole amounts of vertices in here. And it's going to reduce a little bit of these vertices so that you can render millions of them in the scene without any problem. And when the player gets so far away, for example, from a distance like this, which is barely visible, it's going to show the least amount of vertices to remove the burden that is on the hardware, so that you can render a lot of the instances from this grass into the scene with no problem. Because in games, it's all about faking. And the more you can fake things, the better. Because when the player is to something far away from this distance to the object, they need to see just a silhouette, not all of the mesh with all of its glory and complexity. So this level of detail is here to help us achieve that goal. And this LOD is specific to the games. In a Speed3 Cinema version, we had a resolution bar in here which included high, medium, low, and draft. That works somehow as the LOD system for cinema version. But right now we're talking about the games edition, and we're going to create LODs. So to set up LOD for your model, you need to go to this tree, and in this tree, in these tabs, you select the LOD and hit enable. And it's going to create the LOD system for you. But right now you're not seeing anything because the number of LOD is just one, and it's the main one that is being shown here. So we need to increase the steps of the LOD system to be able to use this one. So I'm going to increase the steps to something like 3. And now you see in here we have a slider which really can help us visualize that. So if you drag this slider down, just look at the resolution and the amount of complexity of the models. So let me bring this down. Now you see, as I start to increase it or decrease it, the model complexity gets so low until the point that it gets to 1,500 polygons. And this is what is going to show in the far from the camera, where player is going to walk off so far away from the model. And if you're not happy with the result that you're getting, do not be sad, because you have the maximum amount of controls to customize the level of tree of your tree. If you want to make this transition automatic, instead of using this slider to go up and down, you can click in here, and instead of manual, choose one of these presets. So for example, let's hit close. And now when we get far away from this, you see the transition happening. And now we're losing the poly count as we go far away from this. And this is something that happens in games as well. The farther you get away from the model, the less details are going to be shown on the screen. And the default mechanism for that is it's going to guess out the parts that are in the interior of the object and parts that are most likely not going to be seen. For example, in that bush example in here, it's going to guess out the parts that are in interior. For example, these parts, and first remove these, and after that coming for exterior parts as well. And this is what it's doing for the grasses as well. It's going to first remove the interior, which is now the center, and it's going to shrink them in size, and then after a bit just completely removing them to the next LOD so that the transition will be seamless. Instead of knocking them out, it's going to first shrink them a bit in size. Let me show manually. It's going to shrink them in size just a bit, and after that removing them, and not using the knockout system just to hit them to make the transition ugly. It's going to first shrink, make them smaller, and then completely remove them in a seamless fashion. And you can customize that to tell a SpeedTree which parts should go first. And to do that, for the global setting, you come in here, and these are the profile curves that allow you to do this. One for branches, decoration, leaves, and fronts. In this case, we're only manipulating the fronts. So let's go for fronts in here. The left side is for highest LOD, and the right side is for lowest LOD. And if I bring this really down and go for the lowest LOD, since this is on automatic, let's get a distance from this. Now you see on the lowest parts of the LOD, it's really showing nothing because I brought it really to absolute zero. And this is not really what we want. So let's bring this one up. Now in this distance, it's showing geometry as well. So let's go in here. And this is really dependent on what type of game and what PC you are going to create game for. For example, if it's really a demanding game, a high quality open world game, you might want to bring this one up so that in medium detail, in medium distance also, it shows the high quality and then goes far away. So let's go. Now you see in this distance also we are seeing the full quality. And if we go down to such a distance, we start to see the LOD change. It makes the transition to your own liking. So let's take this one and delete it. Of course, the best way is to be optimized all of the times. And the same goes for these as well. The left side is for the highest LOD and the right side for the lowest LOD. And this is the transition that is happening in a linear fashion. And the next setting is special for the leaves, because leaves are a bit special to this one. So let's hide these. I'm going to hide to have a study case on the leaves. So selecting the main tree, I'm going to create a trunk, and then adding the big branches, twigs, and then leaves. So this is a small procedural tree that we created, nothing too special. So let's go for here, the leaf settings. The first one is the grow scale. And basically what it does is that when you get far away from the tree, it's going to cut off some of the leaves. This is what LOD does, so normal. But to keep the shape just a little bit in there, it's going to rescale the remaining leaves, just to fill up the space a little bit. So let's bring this down. And now you see, instead of keeping the leaves, it's going to remove some of leaves, and rescaling the other leaves as well to 2. So if I bring this to something like 3, it's going to increase the remaining leaves to be larger, just to fill up a bit of a space. And the jumble value is going to determine a bit of randomization in that to see which trees and which leaves should be removed. You can manipulate that to randomize it to find a good spot that keeps the shape of your tree. So let's bring this one to 2. And you can manipulate that to your liking. And the next one is seed, and it's going to ultimately randomize using this random value. And now we are seeing the lowest LOD possible. And if you want to manipulate the LOD for each one of these, you can do that. For example, for branches, for decorative leaves, or fronts. Just the same way that we manipulate the front. The left side is for highest LOD and the right side is for the lowest LOD. And this part is the maximum amount, and here is the minimum amount. And we're not going to the minimum amount for these because we want a bit of geometry to be rendered in the scene. So these are the global settings, and of course you have some settings in each generator as well. And if you select the generator and go to LOD, you're able to customize it very much, regardless of other generators, to determine which part is the most important for you to stay there. The first one is weight, and it's going to override what you have set in this property in here. For example, now all of them are the same. As you get farther away from the tree, it's going to be reduced. But if you manipulate the weight properties, you're going to offset that. For example, if I go to a specific generator like this one, let's think that this is the most important part for us. So let's increase the weight to something like 2, for example, and then bring this slider down. You see all of them get faded, but this one is going to stay the same untouched. And if you bring the weight also up, for example, to something like 20, you see little changes happening to this. And this is important if you have a specific part of your tree that you want to preserve from the changes of the LOD. This is the way to go. So let's set this to default. And the next option is the optimization, and it's good for reducing the amount of the complexity of the mesh, especially for the amount of vertices that it has. Let's go to script mode and start to visualize that in here. And I have selected the trunk, the main trunk, of course, and I'm going to increase this optimization value. So now you see nothing because we're on highest LOD. And let's bring this down, and you see a dramatic change in the amount of vertices that it removed. And if I decrease it to the default value, which is 0, you see the more amount of the geometry it has preserved. And to accompany this, there's the length and the radial segments. So let me again set this one to 1. Now we are seeing the lowest LOD. And let's bring the radial segments down, for example. Let's go out and let's set the mode to min. And now you see even more it has optimized from that. And it's removing the radial segments even more using this parent curve. So let's set this to max, which is the default. And also you can use this profile curve that the optimization has to control the amount of the optimization to each generator. For example, if you want to be in the middle and not deleting everything, you can choose this. So this is about setting the dynamic LODs, and I'm going to hide these because I really do not need them. And let's go for, and now we have them here. And this was the first method of optimizing things for being used in the games. Of course, you can go further. You can remove as much vertices as you want. Or for example, creating an importance value for this interior section which gets faded away to make this one stay on top and do not create this bald effect in here. So I'm going to create a new save file from this because we're going to take a screenshot just like the bush section, and use another method to create game-ready grasses. This method that we thought already is very good for high quality games, but if you want to go a bit lower, for example, creating a mobile game or creating even more optimized game for PC, I'll see you in the next lesson, creating a new method.